All right, taste at 213 people. So we're gonna get started on kind of a new topic today. So we're gonna spend at least this week and next week talking about logistic regression. And so we'll see some similarities between this and multiple regression as well as some differences. And so let's go ahead and get started by just defining what logistic regression is. The definition's pretty simple. It's just regression methods for a response variable that is categorical. And more specifically, for a response variable that is categorical with two categories. And so typically this response variable is coded as zeros and ones, just like our indicator variables were typically coded as. And so right away we just see the difference between this and what we've been doing before. Everything that we've talked about day 1 through 20 has assumed that our response variable has been quantitative or numeric. So you could think about all those examples and everything that we did when we had wine quality or set duration in volleyball. Every single example that we had a quantitative response. Now our response variable is going to be binary, meaning categorical with just two possible categories. So for example, non-smoker or smoker, or like a win-loss type deal in sports would be another common example of this. And so let's begin our discussion by just talking about why we can't use what we've been using before. And so throughout this note packet, we're going to use this example of colleges in the US. And so United States colleges, our response is going to be the institution type, so either private versus public. And we're going to assign public as the category that gets the 1, private as the category that gets the 0. We're doing this because that's how R is going to end up defining it when we enter it in as code. And so we're going to start just considering student to faculty ratio as the predictor. So before we even do this, we might kind of think about, well, public schools will probably tend to have a higher student to faculty ratio than private schools. So there's some code to kind of make this following plot, but this plot we're going to talk about in a second isn't right. And so this is what would happen if we just used what we did before. We just used this LM function to fit the model, and then we plotted it with ggplot, and we added the best fit regression line. And so take a second to go ahead and pause the video and ask why, like what doesn't really make sense about this plot. In particular, what doesn't make sense about using this line to kind of fit this model with institution type as the response. Okay, did you pause it? Hopefully you paused it. So, I mean, there's a bunch of things you could have said, like one would be, okay, well, my prediction down here for a student faculty ratio of about 7 looks like my prediction is minus 0.25. And so that just doesn't make any sense on any sort of stretch. And keep in mind that we've had nonsense predictions before, but when we had these weird predictions before, we were extrapolating. Whereas here, we're not extrapolating at all. 7 is within the range of x values. So it's not extrapolating, but we're still getting this really strange prediction of negative 0.25. Other reasons you could have just said, okay, well, what does a 0.6 prediction mean? If our response is coded as zeros and ones, how am I to interpret this 0.6 prediction? So hopefully that makes sense as to why we can't use what we did before. So then what can we do? And we're going to start by just talking about this model for the mean response that we did before. This was way back in like day 1 or 2. We wrote out the model like this, where we're modeling the mean response as kind of this linear function of our predictors. And that's why we have this kind of average interpretation that's necessary when we make all of our interpretations. If we code the response as a 0 or a 1, then the mean response has this special meaning. And in particular, the mean response is now the same as the probability that y is equal to 1. In other words, if we wrote that out in symbols, our mean response for logistic regression in this case is going to be equal to the probability that y equals 1, where I'm just using this kind of shorthand notation, capital letter P, to mean probability. And so often our mean response in this setting has this relationship with x, which is our predictor. And so often, if I were to put that probability on the y-axis, it's going to look something like this, where it kind of maxes out at 1 and has a minimum of 0 because it's a probability. Or if it were a negative type of relationship, it looks something like this. And so if we were to write out the form of this curve, which is only an approximation mathematically, this is the mathematical form that we're going to use for our logistic regression model. And so let's define a couple things here. We're going to let this Greek letter pi, that's going to be the probability that our response is equal to 1. In this case, that's the probability that the university or college is public. Oh, blurg. Stupid thing. Okay, that's better. And so another kind of notation-y thing is this exp. That, it's written in text down here, is equivalent to this Euler's constant thing. And so that's, the exp is what you would enter into R. To find like e to the 4.2, you would enter in exp open parentheses 4.2. Okay. And so then just based on this, our this equation here, our predicted probabilities, which we're going to denote as pi with a little hat on its head to denote that we're predicting, are just going to be like this, where we're going to grab these fitted regression coefficients from R. Graphically, our predicted probabilities are now going to be on the y-axis for this curve. And so now, like a 0.6 is going to make more sense because we're saying that, okay, we're predicting the probability of a university being public. Also, since we have this curve, it has a minimum of 0 and a maximum of 1, so we're not getting any negative predictions. And so now, because of that, our predictions make sense. Okay, so it's kind of a little difficult to get going with this, but I'm hoping after the next video, if any of that kind of is a little bit fuzzy, it'll start to make a little bit more sense. As always, let me know if you have any questions.